Hey guys, welcome back. Today we're going to be talking about the unit circle. We're going to be splitting it up into angles, which means degrees and radians. Yeah, so we're spending some time on this unit circle. Again, it's very important for us to understand how it works and how it all fits together. So we're going to take some time. We're going to make sure that you guys are good with what we're doing here. So first off, let's label the axes. We have our y-axis and our x-axis. Those are not going to play an important role just yet, but soon they will. So let's start off with degrees. So let's do this in, let's do it in red. So red would be the degrees. So what we said earlier was that we start at 0. And in standard position, we start off at the positive x-axis, which we just highlighted in red. If we do a complete rotation around this circle, we should go 360 degrees. That's something that you are familiar with from geometry, and you probably picked it up in elementary school, and we've been understanding that one time around the circle, or a complete turnaround, is a 360 degree angle. So let's start with that. If we go halfway around the circle, then that would be half of 360 degrees. That would be 180 degrees. And then if we do halfway between 180 and 360, or 180 and 0, actually that would be 90 degrees. So our y-axis represents 90 degrees, the positive side of it. And then if we do it halfway between 180 and 360, that would be 270 degrees. All right, so what we're going to do from here is we're going to split up each of these quadrants. We're going to make triangles in there. So you have one triangle here, one triangle here, one triangle here. Now, we talked about special right triangles last time, and these are your 3 special right triangles. So again, we're going to refer to the central angle here when we're talking about these triangles. So this first one is going to be a 30 degree here. The top would be 60. We're not writing that in, and we always assume the bottom is a right angle. So this is going to be 30 degrees. The next one is the next special right triangle. This is going to be a 45, 45, 90. So the central angle is 45 degrees. And the next one is the same as the first one we started with, except for it's standing up. So this one is going to be 60 as a central angle. And then the other one would be 30, and the bottom, again, would be a right angle. So notice that the right angles are always connected to the x-axis. That's how we're going to draw our triangles. And also remember that the hypotenuse is the radius, so they should all, well, this one doesn't exactly, but it should touch the outside of the circle, and our radius is always going to be 1 for a unit circle. All right, so likewise, so this is quadrant 1. In quadrant 2, we're going to do the same thing. So these are just the same, whoops, that's gross. These are the same exact triangles, except for flipped over the y-axis. Their orientations are the same. The angles are the same. It's just they're in a different quadrant. So if we add 30 to 90, we get 120. Then if we add 45 to 90, we get 135. And if we add 60 to 90, we get 150. So those are the angles and the related triangles in the unit circle. Should probably change color. It's getting monotonous. And then likewise, if we start at 180 and we add 30 to that, then we have another triangle here. This is going to be 210. And then we have this 45, 45, 90 triangle here. So if we add 45 to 180, then we get 225. And then if we add 60 to 180, we get 240. Sorry, that's not very straight. There you go. Again, the last quadrant, quadrant 4, so this is Q3. This is going to be Q4. All right, we're adding 30 to 270. That's going to give us 300. If we add 45 to 270, we get 315. And if we add 60 to 270, we get 330. All right, so that's all. That's all the degrees that we're going to be concerned with the unit circle. And notice again that all these triangles, they repeat themselves, right? So this triangle here that we started off with looks a lot like the triangle here, which looks a lot like the triangle here, and that looks like a lot like the triangle there. So for every triangle we have, there's 3 others that are in the same orientation but in a different quadrant. So that works for the lying down ones, it works for the 45-degree ones, it also works for the standing up 30, 60, 90s. All right, so now let's talk about the radians. Let's do this in purple. All right, so let's clean this up maybe a little bit. I'm gonna take out as much of this as we can. All right, so just like we split it up when we were doing the degrees, we're gonna do the same thing when we're doing radians, but we have to shift our thinking, right? Because we're so used to thinking that one complete rotation around the circle should be 360 degrees, which is correct, but that's not gonna help us out when we do radians. So for our radians, we said that radians also starts at 0. And we said one time around the outside of this circle would give us 2 pi radians. So 2 pi is the same thing as 360. We talked about that when we did our conversion in the beginning of class. So that means that if I'm going halfway, right, halfway over here between 0 and 2 pi, that would be half of that. That would be just pi radians. All right, so know that 180 degrees is the same thing as pi radians. If we go up here, if we go halfway between 0 and pi, that would be half of pi, which is pi over 2. And then likewise, if we go halfway between pi and 2 pi here, that would be 3/2 pi. All right, so maybe it might be a little bit better if we do this on another sheet. Just know that the degrees correspond to the same radians. So let's go to a new page. I'm just going to fill this out roughly. I know my circles aren't perfect, but we'll figure this out. Just going to quickly draw these triangles in here. Sorry if it's a little messy. It's basically what we just drew. On the last sheet, just really rushed. Okay, so we also just said that 0 radians is the same thing as 2 pi radians. Halfway between one whole rotation would be pi, which is half of 2 pi. This one would be pi over 2 because it's halfway between 0 and pi. And then this one would be 3 pi over 2 because it's halfway between 0 and 2 pi. When we're doing the conversions, we said that we take our degrees and then multiply them by 2 pi over 360. If we were to do that, we'd find that the 30-degree angle would be pi over 6. So one way to do the radians is to do all the 30, 60, 90s as jumps of pi over 6. So this one would be 2 pi over 6. 2 pi over 6 is the same thing as pi over 3. And then if we jump to the next one, that would be 3 pi over 6, which is pi over 2, half of a pi. Then if we jump over to the next one, that would be 4 pi over... Oh, sorry. 4 pi over 6. I didn't mean to write that. It's definitely 4 pi over 6, but 4 pi over 6 reduces to 2 pi over 3. Then the next jump over here would be 5 pi over 6. 6 pi over 6 is the same thing as pi because 6 divided by 6 is 1. Then we have 7 pi over 6. Then we have 8 pi over 6, which reduces to 4 pi over 3. So if you're good at fractions, this is making sense to you. If not, you might have to take some time to have it sink in. Then 9 pi over 6 is the same thing as 3 halves pi. Then 10 pi over 6 reduces to 5 pi over 3. And then 11 pi over 6. And then we're back to 2 pi. Now notice when we did that, we didn't do any of the 45, 45, 90s. Those live under different rules. But if we were to convert like we did, 45 times 2 pi divided by 360, we'd end up with getting pi over 4. So what we're going to do is for every jump of 45 degrees, we're just adding pi over 4. So if you notice, if we jumped back to the y-axis here, we'd add another pi over 4. That'd give us 2 pi over 4, which is just pi over 2. So this one still stays, even though technically it is 2 pi over 4 if we're jumping by pi over 4s. This next one here would be 3 pi over 4. Then we'd hit the x-axis again. That would be 4 pi over 4, which is equal to just pi. 4 divided by 4 is 1. Then we'd have 5 pi over 4. Technically, this one right here would be 6 pi over 4, but that reduces to 3 halves. And then the next one would be 7 pi over 4. All right, so if you're not familiar with radians, which a lot of us are not, and are not comfortable with fractions, it might be a little bit confusing at first, but just note that for all the 30, 60, 90s from starting at 0, each time we jump to the next triangle that's 30, 60, 90, either laying down or standing up, that each time we're adding pi over 6. So we can go around, work our way with the pi over 6s all the way around the circle. As long as we reduce our fractions, we should be fine. And then we can do our pi over 4 separately. Those are the 45, 45, 90 degree ones. These ones here, the middle ones. And each time we jump from there another 45 degrees, we're just going to add another pi over 4. And again, we're going to reduce it to get the proper fraction. All right, so this may be a lot to take in for right now. We're going to practice it. You're going to practice it just so that you're comfortable with how the angles go before we start actually putting in the values next time. So take your notes down. Make sure if you have any questions, again, write them down, and then we can talk about them in next class. All right, see you later.